Okay. Can you guys hear me? And can you guys see my screen?
Yes, can see you and hear you.
Brilliant, fantastic. All right, lucky last. Thank you for intro, Claudius. Very kind of you. So I lead the custom engineering security practice for the Greater China region, and what I want to do today is to tell you some stories. Okay, something light, not too much about the product. So our theme today in the entire summit is all about zero trust. Now, talking about zero trust, we have to talk about our traditional way of doing security. And Google is a company we used to do exactly the same, the traditional way we used to do. But that was one pivot point. We came to a realization and we pivoted and we tested different methodologies and we provided our own learning to a framework that everyone else can use. So at Google, we all know Google is a company actually builds a lot of products everyone use. In fact, billions of people using them every day, such as Google Search, YouTube, and Gmail, etc. So all of these products we've built are under attack on a daily basis. Every single second they're being attacked. So it's very important for us as a vendor to produce those products in a safe and reliable way, not only to protect the product themselves, but also to protect, most importantly, the people, billions of people using those products. So many years ago, that's wrong, not many years ago, okay? Not many years ago. So I still remember at a community meetup in Australia, I talked about one thing, I made one comment. I talked about the traditional way of doing security, the walled castle perimeter is not working anymore, okay? Now, because if we think about the things that we put inside of a castle to protect them, such as the identities, such as the applications, the data, all of them are actually leaving the castle these days. Your organization, who you work for, yourself, if you're running your own business, you will use SaaS applications. You may have a cloud-based IDP, identity provider, etc., etc. So the castle's still there, but things that's supposed to live in the castle are actually leaving it. So once I made that comment, I looked around the floor at that community meetup. And most people at the time, they were either holding their arms up or had a massive frown on their faces. Now, fast forward to today, I will still stick with my same comment, but with a little bit of elaboration, okay? I wasn't advocating of getting rid of the firewalls, etc., but rather perimeter security, perimeter-based security alone is just not enough. So this is a story by Google. So back in days at Google, we had walls, we had castles, we had all the drawbridges and everything, just like medieval time castle we built that, and just like any other traditional enterprise. It was in 2009, our walls in front of the castles failed, okay, in December 2009. So what happened in 2009 was the world had one of the largest organized cyber attack sponsored by nation state. It targeted over 20 technology companies in the world, predominantly in the United States, with the aim of having access to the source code of those technology companies. And Google was one of the targets, okay? The operation was very successful. And later, when the McAfee, the malware crew and the chief technology officer at the time, when they unpacked the malware binary, they found out there was some keywords in the malware binary. It's called Aurora. So the entire operation was named Operation Aurora. It's very famous. So attack Aurora Operation Aurora attack against Google was very classic phishing attempt. So entire thing started with someone messaging a Google employee saying, hey, look, blah, 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 is that you? And with that particular question, a sentence with a question mark, there was an attachment. Attachment was a JPEG file, okay? So essentially it's like someone asking, hey, this is a photo, is that you? At the time, unfortunately, the employee and the engineer clicked that button, and inevitably that was the entry point for the attack to get into that systems. Now, at the very beginning, in 2009, we didn't have a great process in place to really thwart this kind of attack. And the attackers are really sophisticated as well. They were able to use the entry point to expand outside of where they were. Initially, there was just one Windows server at the corner of a data center for the testing purposes, but because that particular server was acting as the jumping board, a springboard, helping them to jump from different places. So we scrambled, we got all the people from around the world to bring together, trying to solve this instance. And at the end, how we purged the entire operation was very brutal. We basically reset the password for everybody. And that's when we woke up, but we thought, hold on, this is not the way, like we cannot afford the same thing from happening again. So we did our post-mortem, we learned, and that was the beginning of we thinking about how do we build zero trust in our systems. So all of those are story, a little bit of advertisement. If you go to YouTube, if you search hacking Google, there is a series of documentary we recently announced, all about the backstories like the one we talked about. Nothing to do with products, you can go watch it. Great story, great documentary, talking about how people at Google do their security. How do they do their own things to secure billions of people in the world? So do watch that, very good documentary series, very well done, the production as well. So on that story, I really want to talk about that walls just don't work, okay? The walls don't work. So on that story as well, 2009 until now, quite a lot of number of years passed. So what we have developed is our own way of zero trust approach. So we gave zero trust approach actually two key initiatives in Google. We have the BeyondCorp and also have the BeyondProd, okay? So BeyondCorp essentially is what we do to help the users, end users, to access the critical applications or any applications in Google. So these users are Googlers, me or my colleagues, our temporary employees, our vendors, our partners, etc. How do we allow those people to access applications anytime, anywhere, with the security in place? And also to making sure all interactions, those people with applications having appropriate authentication, authorization, and auditing entire chain of trust in place. That's what user accessing application found. That's one of the initiatives we call it BeyondCorp. And that also, around 2 years ago, we turned the same learning and the technology stack into a cloud product called a BeyondCorp Enterprise. So if you're interested, look it up, BeyondCorp Enterprise. Essentially, that's exactly the same technology I use every day. Any Googler use every day, okay, for zero trust network access. And going down the bottom part, which is BeyondProd, which is what I really want to talk about today, is around how we as a company build our applications, our products with a zero trust by design from the day one on the get-go. Essentially, if you look at the left-hand side of this slide, the identity is the centerpiece of the entire zero trust story. And identity is not just talking about humans, users. It can be different things. It can be your devices. It can be your services, etc. And surrounded by identity, that's the entire attributes of identity, such as time of day, such as where is IP address coming from, and how often is IP address and identity combination accessing certain applications. All of those can become very critical signals and attributes for you to build your zero trust policy verification. Now, for the BeyondProd part, really we're talking about three things over here beyond identity. We're talking about how do we give each of the individual machines, each of the individual containers or services in our sense, because Google runs the largest container workload in the world. And how do we have the binary authorization? Essentially, binary authorization is how do you ensure every code, every piece of binary running in the production has the entire chain of trust that indeed the source code was developed on a trusted laptop IDE, and the source code has been packaged, turning into the binaries or packages, etc., going through the corporate continuous integration system, where the continuous integration system has all sorts of security checks and balances in place. And also, this piece of software or code have gone past those security checks and balances. So you have the entire chain of trust and provenance. The last one is policy enforcement. I think one of the challenges, if anyone on the line, you are an application developer, you will find out one of the challenges you may have is often lots of the traditional software will have the logic of authentication and authorization close to the application as the entirety. That's okay, but it's not really scalable, because very often as an individual, as identity, human identity, or user identity, we often have to access multiple applications, probably more than a dozen, right? If we have decentralized the way of doing the authentication and authorization, it can become out of hand really, really quickly for the security team, or for your centralized operations team or SI team, whatever you want to call it. So these are the three key things you might talk. So BeyondCorp Enterprise, I can talk about it different time, and we're going to focus on BeyondProd. And Claudius and folks, please keep me in check my time. So I'll probably spend a little bit more time on the stories. I like telling stories. So cloud native architecture, there are many definitions. This is one of those definitions, okay? So in Google, we run largest container or microservices architecture for the products in the world, full stop, okay? So at the backbone of it is something called a Borg. So Borg, for people who are Kubernetes enthusiasts, you will know Kubernetes actually is based on the Borg. So essentially we take the Borg, we open sourced it, and it was called Kubernetes. And different vendors took Kubernetes and developed managed versions to make essentially everyone's life a little bit easier. So they have managed control plane, and they give it the node groups to the people. People can just worry about putting on the containers on top and then run them at a scale. Now, this kind of architecture, microservices architecture based on containers, many people define it as cloud native. And in my talk today, I'll really focus on this part. So how do you secure cloud native workload or cloud native architecture? Okay, it doesn't have to be in the cloud. You're probably running your OpenShift on-prem, still applies. So there are a few principles when you are approaching this kind of cloud native architecture or microservices, a container-based architecture. The first one you want to do is to making sure you protect your network at the edge, because essentially, if your application is facing your end users, you wanted to make sure you build your security, build defense very close to where the traffic is coming from, okay? Because when you're exposing your applications to, for some of the folks online, if you're working for the company, or if you have a company developing applications for what we traditionally call B2C companies, mass consumer facing companies, that's very, very important. The second thing you want to do is, it's difficult, I admit, okay, but the second principle is do not have any inherent mutual trust between services. So often when people run a workload on Kubernetes, things come in, it's fine. You probably have some load balancer or ingress control, that kind of stuff, to ensure there's proper authentication in place. But once traffic goes into your Kubernetes cluster, it's free flow. All the pods can talk to each other, no restrictions, that kind of stuff. And even for pods talking to pods, there's no authentication or authorization in place. No good, okay? I understand it's hard, but remember, this is the principles, this is the target state, this is your North Stars that you have to look every time when you go towards a proper way of securing cloud native architecture. Now, the third thing is making sure that the machines, at the end of the day, you have machines, irrespective if they are virtual machines in the cloud or your bare metals, or even your VMware kind of infrastructure, all the machines running the code, you will have to have known provenance, essentially the chain of trust I talk about. You have to have the confidence to ensure the code you're running on the trusted machines, and all the code running are trusted as well. So how do you realize that? There's several ways, but one of the ways we embarked on is around digital signature. So making sure every step when you're building the code, when you're deploying the code, at the end, can you drop certain container onto your Kubernetes cluster is also based on digital signatures, because digital signatures basically is one way, it doesn't lie, okay? People cannot tamper it. Now, the fourth principle is having a policy enforcement point, being consistent across different services. Now, if you go to NIST standard, there are different ways of deploying zero trust architecture, and we took one of the approach at Google. I'm not saying that's the only one. It's like NIST has 4, right? You can pick one of them, but I'm talking about the one Google does. So we took the policy enforcement point outside of the services as a centralized tier. So that way, from the SIE teams or from the security team's perspective, you can go to one place to look at the entire thing. And also you can ingest, update, and enforce your policies at the one place that will propagate to all the different containers running on the different places as well. Now, the second last principle is to have a very standardized way to roll out, because we know container, one of the most critical thing about containers is containers are immutable, essentially. You don't patch the containers on the go. You rebuild them with a newer version, with the patched version, the good version, and roll it out. So in order to have that capability, you have to have a standardized way of rolling out the changes, swapping out the containers, etc. So that's great from the DevOps perspective, from the time to market perspective. It is also fantastic from a security perspective. Okay, I'll give you one very simple example. Log4Shell, not too long ago, okay, at the beginning of this year. So imagine at the time you were very good in identifying impacted, affected binaries, packages, great. But then if you have challenges, you didn't have a standardized way of rolling out changes, you may be struggling to patch those vulnerable packages, right? Because, if I roll out a change, there will be a, production blackout, or maybe I break something that's running in production, that kind of stuff. But if you have practiced your muscle to have this standardized way of rolling out, you don't have to worry about that. And the last one, also very important, containers, we all know, sharing all the hosts and different, sharing the same kernel and different containers on the same VM. And even underneath the VM, you have the bare metal that's hosting the virtual machines, etc. So most important thing is have another layer of isolation, which is also what we do at Google. We use something called a gvisor, I talked about in a bit. So these are the principles you should always look at as your guiding principles, your Bibles, when you run cloud native architecture, when you're trying to secure them. I understand you're not going to get there in one go. Even Google, some of the things we're still running, we're still trying to perfecting them on a daily basis, but these should be your principles. Now, this is a slide really talking about how we do it for each of the principles from our product perspective, product as in Gmail, search map that you probably used today or just now, right? So how we secure those applications that are running in a cloud with a containerized architecture. So Google front end essentially is our global infrastructure closest to everybody. So if you travel to the United States, in San Francisco, you browse to YouTube, you want to watch a video, and the same video you want to watch in Hong Kong, you will find the experience is the same. Because why? Because Google front end provides you the same experience, same kind of performance wherever you are in the world. And it is the same infrastructure that will front all of our products. And at that particular tier, we talked about at the edge tier, we're going to run things like your traditional TLS inspection. We're going to run our, very, very standardized, everybody needs to do it, DDoS protection, layer 3 and 4, and layer 7 kind of protection. All of those will be done at that tier as well. Now, beyond that, we also have the first layer of defense built on the Google front end tier. And that's what you need to do as well. Irrespective if you're using Google Cloud, which if you're a Google Cloud customer, you are essentially using the same infrastructure, okay? So if you're using Google Cloud layer 7 DDoS protection, you are having the same throughput protection as YouTube, okay? It's the same thing. But even using different vendors, it's the same as well. You need to think about how you start your production from that place at the edge, closest to your end consumers. The second thing what we do is the application layer transport security. Essentially, we are enforcing the RPC remote procedure call authentications and making sure the integrity is in place, and of course having encryption by default in and out all the places. Now, application level transport security is also enforcing our mutual authentication between the services. Okay, in the Google infrastructure, it applies to all the service-to-service communication. We don't have the concept of, oh, if you're inside of a certain network, you don't have to have ALTS. No. Everywhere, full stop, okay? No escape. So another one is around how do we provide the provenance I talked about. There's two parts. One is the code, the other one is the host. So from the code provenance perspective, we have internally, we have something called a binary authorization for POC. And we also have the binary authorization product on the Google Cloud as well. So essentially, binary authorization in the simplest form, if I can summarize in 30 seconds, is essentially signing each step of the actions. So if I'm cutting a code from writing Node.js, okay, I have the ID, I bring that to the npm package, and my CI is doing the job. Before CI is packaging to the package, is going to go through your security team's static code analysis, and it will also go through the software composition to look at SBOM, looking at all the packages, see if they're vulnerable, etc. All the good stuff, right? So CI is orchestrating that job. Not only this piece of my code going to the CI and all the security checks and balances, the package is being built by CI. I then sign that particular package, that binary. And that signing essentially means this particular binary has gone through all of those, okay? Now, this is the first part. And the second part is you're trying to take those binaries to build a container, for example. Now, again, I'm going back to the CI to do its own job. So the second part, will I build a container based on the package that I just signed just now? I have not a signature that signed my container. As you know, every time when you build a container, there will be a short shard. So those are unique. You can then sign different versions of container. Every time your container is being built, going to the same CI, etc., it is unique. So at the time, when you try and deploy a certain container onto a Kubernetes cluster, you can set a policy to say, hey, only this particular container that's got a certain signature going to the binary authorization can run in your Kubernetes cluster. So not everybody can run any container on your production Kubernetes cluster. Now, host integration is also very important because most of the people with the blessing of cloud technology don't have to worry about this part, but Google, as we own infrastructure, will have to do it as well. So essentially, we are verifying the integrity of the host system software from secure the booting, the boot processes, and backed by the microcontroller hardware if it's supported. And also hint, the host integrity checks also includes the verification of digital signatures on the BIOS, BMC, bootloaders, and OS kernels, etc. So these are the things, if you're providing services to from the very bare metal level, this is something you need to worry about as well. Now, service access and user context tickets are two things. So service access policy essentially is limiting how data can be accessed between services. Okay. Now, for example, I'm going to give you an example in a bit. So if I'm Gmail, I'm trying to access a calendar. So essentially, you can define what sort of data will calendar provide to Gmail, and vice versa, what sort of data calendar can grab from Gmail, right? So these sort of policies you can define in a service access policy. Now, end user context ticket essentially is me, Ken. I'm logged into the system, I'm authenticated, and the whole authentication ticket or token encapsulates my identity and also some of my conditions, where I'm coming from, and kind of stuff. And this particular ticket is integrity protected and centrally issued as well. Okay, and this ticket can be given to different services, for example, Gmail, calendar, etc., to represent Ken logged in with this condition, is Ken's permissions, etc. Now, second last one around the deployment, Blue, Green, Canary, etc. All the people running good DevOps, you have all of those. So essentially having the load balancer, have a blue-green 2 parts, so you can roll back, roll forward, etc. So those are the good practice. I don't want to spend too much time on that as well. Last one is gvisor, which is the one I talked about, having extra level of abstraction. So I can think gvisor from the Kubernetes or from container perspective is an extra abstraction. It's like the virtual kernel of the actual kernel of your VM. Okay, it's a virtual kernel on top of the actual kernel of the VM. So having gvisor in place, you can have reduced attack surface. Essentially, your containers running on a VM, they're not going to direct access your VM kernel. They're going to go to gvisor, where gvisor allows you to configure different policies. So that gives you another level of abstraction to further isolate the things that are running on the top and the kernel that are providing all the services. So we have all of these things in our BeyondProd white paper and a different blog white paper as well. I'll provide you links at the end of this talk. So this is the one example of me as a user signing to Gmail, and I'm trying to get Gmail to access some data from the calendar. Maybe I wanted to get calendar to automatically create an event based on an email that I received, okay? I think lots of Gmail users will have that experience. It's very convenient. And this particular diagram is behind the scene of how that worked in different components. Conscious of time, I'm not gonna unpack this one, but it's got all the dots and flows telling you all the ALTS, that kind of good stuff. How did it work in action to help you to realize that that particular user journey of having a calendar event created from your Gmail. Now, how do you do the same thing with Google Cloud? I talked about before, lots of the things in Google Cloud, if you are the customer, lots of things you use are the same thing Google use to build and protect the Gmail, YouTube, and the rest of it. Those products you use every day. So from the edge protection perspective, you have a load balancer, Cloud Armor, WAF, the kind of products. Essentially, with the load balancer and the Cloud Armor WAF, you have exactly the same level of protection as YouTube. Okay, I think around June this year, Google Cloud, the combination of a Cloud Armor and a load balancer, defended largest recorded DDoS attack in the world. Okay, non-stop. So just give you a scale of that attack. We all know Wikipedia. Wikipedia is a very, very famous website. It's top 10 in the world, in fact. So for that particular DDoS attack, it took only 10 seconds of that attack to reach the daily Wikipedia request number. Okay, it only took 10 seconds of an attack. So you know the attack was really, really large. And then we were able to defend that attack. So on an end user, a customer who's running on GCP, they were fine. And of course, the end consumers of the applications were fine as well. Now, since I was talking about containerized applications, how do you run no inherent mutual trust between the systems? You need to drop so Anthos is our product, but if you want to use, if you're not on GCP, that's fine as well. Or if you're running on-prem, you want open source, okay as well. So you need to bring in a service mesh story from Istio, okay? So with the Istio Anthos service mesh, you can enforce mutual authentication and also the centralized policy enforcement. Now, workload identity and network policies are some things very specific to our GCP. I don't want to spend too much time selling those products, but essentially you don't have to have a static credential to access some other GCP products. For example, if you have a pod running on Kubernetes cluster, you want to have that pod to access a cloud storage. And how do you do it? You can give that pod a static secret like an access key or JSON format of credential of some sort. Okay, that will work 100%. But is it good? No good, because any static secret is no good. It's very difficult to rotate them, and it creates another attack surface. And the workload identity was introduced to solve that problem. You don't have to have that static secret. You can just assign identity to the pod, and pod will, with right permission, can then access the cloud storage. Now, binary authorization, which is essentially the same thing we use at Google, and it's the same technology we bring it up to the Google Cloud customers, gives you the ability to sign each step of your build processes. Now, shielded GKE nodes essentially is the part talked about, very similar to hint, that gives you the ability to secure, have a provenance all the way from the boot time, your virtual machine boot time, okay, all the way to the nodes that can be running your pods on the top. Now, having a centralized choke point where you can write your policies, enforce the policies, update the policies. Again, they're going back to the Anthos story. Now, Anthos config management gives you the ability to configure hundreds of thousands or even more than tens of thousands of Kubernetes clusters in a standardized way. So you can write configuration of what Kubernetes clusters will look like in one place and propagate them out. It also will help you to monitor the drift. So if someone changes the settings, you will know, or can you have the Anthos automatically change the back to compliant state. Now, policy controller and the service mesh work hand in hand as well. So policy controller, again, if you're running open source, no problem. It is essentially the open policy agent at the mission control. So you can enforce the policies right in front of the Kubernetes API. So all the Kubernetes API calls will have to go through this policy controller or OPA at the mission control to be able to execute the command. So that way you can control what people can do to operate and interact with the Kubernetes cluster. Now, software delivery shield is something right now, today, we announced on Next 22, look it up. So essentially that's our story around CI/CD pipeline and how do we build security around it. Last one, gvisor talked about, same technology on Google Cloud. It's a GKE sandbox, exactly same technology. We also even built the operating system for you to run your containers, the container optimized OS as well. So I know I probably spent more time than I was allocated. The last one is a set of white papers for you to read. Yeah, so take your time, a glass of wine, beer, or scotch, or just orange juice, your choice. Good read. And thank you very much for your time today.